Let's wrap up chapter 25 with concept 25.6. It says evolution is not goal-oriented. So we want to talk a little bit about how evolution works. And I know we've talked about this prior, but some people have the misconception that there is a purpose or there is a end goal in mind, that nature is somehow working toward creating a perfect example of a certain species or creating better, stronger, smarter. Or, for example, some people think that the species that exist today must somehow be better or more advanced than the species that existed a million years ago. It's not exactly how it works. Evolution is like a tinkering process. It's a process by which new forms arise by the slight modification of existing forms. And evolution doesn't have any sort of end goal in mind, and it can't create what it wants to create. There is no want. It just works with what it has via the process of natural selection, simply trying to better match the animal or the creature to its environment. Over time, such tinkering, such working with what it has led to three key features that we talked about in the natural world described in chapter 22. The striking way in which organisms are suited for life in their environments, the many shared characteristics of life, and then the rich diversity of life that we see. It's very rare for new parts, for evolutionary novelties to simply appear without some sort of precursor, because that's not really the way evolution works. Now, that's a possibility. You could have some sort of major mutation, or in particular we've talked about perhaps some sort of major mutation in a control gene, a Hox type gene, and that could lead to a major anatomical change. That's not usually how it works. Usually what happens is these biological structures evolve over a long period of time in many stages from previously existing structures. It tends to be a step-by-step sort of gradual process instead of a suddenly pop and there it is type process. A great example is the complex eye, the camera type eye that humans and a lot of other mammals have. That has evolved from simple photosensitive cells, which are very, very rudimentary, all the way up to what we have as humans. And that has actually happened multiple times. The formation of a complex eye has occurred in a couple of different ways, a couple of different times. And there are a variety of creatures that have all sorts of different eyes, from what we might consider the very simple all the way up to the type of eye we have. Vertebrates, which would be, say, any animal with a backbone, and complex mollusks, such as octopus or squid, they both have complex camera lens eyes. So a squid or an octopus and a human, they have eyes that are very similar. But they actually didn't come from the same process. They evolved separately, and they are identified as evolving separately because they have differences in structure and function. They work the same way, but the way they are put together is actually quite different. And as a matter of fact, the eye of a squid or an octopus is a bit more efficient. It's better put together, it's better designed, if you want to think about it that way, than the human eye is. Of course, there is no evolutionary goal in mind to create the perfect eye. It's just through the process of natural selection that this has occurred, but it has occurred on multiple occasions. Some argue that if the eye needs all of its components to function, well, then a partial eye would have been of no use to our ancestors. As if the eye has, say, let's say the human eye has 10 different parts, and they tend to think that a while back perhaps only 9 parts were there, or then only 8 parts were there, and if you didn't have all 10 parts, you're not going to have any good parts to it. You're not going to have any benefit. But that's pretty much a flawed argument, and Darwin noted the flaw in this argument because that lies in the assumption that only the complicated eye that, say, a human has is useful. And in fact, there are many, many creatures that use eyes that are far less complex than ours, and they get along just fine. So there are some creatures that have nothing but some light-sensitive pigment cells, and then there are creatures like us who have very complex eyes. So any portion of an eye or a precursor to the eye we have is likely to be helpful. Here's a picture of a range of eye complexity among mollusks. So we're talking about one particular type of creature, mollusks, and they will range everywhere from the simplest, basically a patch of pigmented cells that can detect nothing but light and dark. They can't see anything, but they can detect if it's light or dark, to a very simple eye cup that provides a little bit more, and then a pinhole camera type eye, then an eye with a primitive lens, all the way up to a complex camera type eye. And so you might find this in an octopus, where you might find this in a very much more less complex creature. But all of these varieties of eyes provide benefit to the creature. If you are comparing two creatures, one that has a patch of pigmented cells versus one that does not, the creature with the patch of pigmented cells is likely to have a benefit and likely to have an advantage. So all of these varieties of eyes exist and have existed for quite some time, and all of them are helpful in some way. Another point to make about evolutionary novelties or new features is, while some features such as eyes have kind of retained their function as they have evolved from perhaps more simple to more complex, other structures don't even retain their initial function. They're adapted for other use. So there are some things that they change over time and they begin to have a different purpose over time. These are called exaptations. Exaptations are structures that evolve in one context, but they become co-opted over time for a different function. And a good example, one I've already mentioned, is early mammals saw the transformation of a previous ancestor's jaw hinge bone to the inner ear bones to carry sound. So we have very tiny bones located in our inner ear that help transmit sound from our ear canal into the nerves that go into our brain. Those bones at one time were originally part of the jaw of some of our ancient ancestors, and they have shifted and moved. Not only have they changed shape and size and location, but their purpose has changed. They know their function has changed over time. Natural selection cannot predict the future. It cannot provide what might be best for an animal. It doesn't have that ability. All it can do is improve a structure in the context of its current utility. It can only work with what it's got, and usually that's a very incremental process. So last thought, keep in mind that there is no end goal in mind. For example, some people like to think that humans are perhaps the pinnacle of evolution, that humans are here because evolution has reached its pinnacle, its point, that we are the most amazing and best formed creatures on the planet. That's not really the correct way to think about it. Evolution is a result of the interaction between organisms and their current environment, and if the environmental conditions change, an evolutionary trend may cease or may even reverse. And so yes, we may be well adapted to our current environment, but keep in mind, we don't want to get too big of a head. We've only been around for a few 100,000 years, and dinosaurs were around for millions of years and they got wiped out. So just because you are the current dominant species doesn't mean that necessarily you will stay the current dominant species as the environment changes and how you have these interactions of evolutionary trends. The cumulative effect of all of these ongoing interactions between organisms and their environment is enormous, and we have seen some major changes in the history of life on Earth, and it's through these changes that we have this staggering diversity of not only the existing life but the past life, this diversity that Darwin called the endless forms most beautiful. So we're going to stop right there. Hope you've enjoyed this chapter. It's kind of a long chapter. There's a lot of information in here, so take it in little bites. Don't try to read it all at once. There's too much to do that. Take it in little bitty bites. Don't forget our quiz that we have coming up this weekend. Let me know if you have any questions, and I'll see you online Sunday night. Leave you with this last little diagram here. I kind of like this last little diagram. I really like the way they use this clock motif to kind of talk about some of the major changes that have occurred, and I really like the fact that you can see how humans, our entire species, only takes up this minor sliver of time. So good luck on your quiz. Let me know if you have any questions. I'll talk to you soon. Bye-bye.